Hi there, my name is Chris Mason, and today I'm going to talk to you about high-performance computing and how Acceleware offers solutions for high-performance computing to improve the productivity of businesses and help them bring their products to market quicker. This webinar is a higher level webinar. It's not really focused on anything too technical. It really provides an overview about Acceleware, high-performance computing, how our organization fits into the HPC market, some of the business benefits that organizations see by using our products, and some discussion on the vertical markets that we work in and some customer examples. Acceleware is a Calgary-based company. We were founded in 2004. We're a publicly traded company on the Toronto Stock Exchange under the venture branch of the exchange with the ticker symbol AXE. This slide shows a list of the customers that we work with today, and you'll notice that on this in this list of customers, you'll see a wide variety of industries that can take advantage of our software, ranging from everywhere from telecommunications through oil and gas, military, as well as biomedical applications also. And as we get later in the presentation, we'll delve into these industries in a little bit more detail, talk about some of the benefits that they get from high-performance computing. So why do organizations run simulations? Simulation today in product design is a critical step in the design cycle of a product. The cost of science is becoming more and more expensive, meaning that simulations are used in lieu of actual prototype models wherever possible because it's cheaper and more cost effective than building the prototype. And you can see that by comparing the two pictures in the slide below. The picture in the lower left shows a car impacting another vehicle, and that's obviously a computer model that's being illustrated there, compared against the image on the right where a car is impacting, like an actual physical prototype of a vehicle is impacting a wall. Now, as an engineer or a designer, let's say I determined that the design of the car wasn't as safe as it could be, or the impact of the collision wasn't crumpling the body the way that I would like. It's much easier in the simulation case to change the design of the car, change the material, the shape of the hood, anything to help reduce the impact of that collision. Whereas if I wanted to make a change in the actual prototype, I'd have to rebuild a new prototype to do that test. So it becomes much easier from a simulation perspective to make these changes and optimizations. So why do organizations use high-performance computing? So simulation is preferred, but the issue with simulation is that the computational intensity and the complexity of the mathematics involved is increasing exponentially, meaning that the computations are taking that much longer to complete. Because of that, high-performance computing offers a way to process all of this, or this significant amount of data in a timely fashion. It allows the designers to run larger problems, use improved scientific models, so increase the accuracy or the realism of an equation, of a mathematical equation, to better model what's happening in real life. It allows for more capacity, so more iterations, more design iterations, or even, for example, separate product designs, so a small-sized or a compact car versus a full-sized sedan. It also allows for increased competitiveness by bringing products to market quicker, and or optimizing the product design to reach an optimal solution for performance or usability from the end user's perspective. So what is high-performance computing? The classical definition of high-performance computing refers to supercomputers or clusters of computers. Clusters are typically built from widely available computing components, so typically just conventional processors and memory. But it really, the industry really covers anything that involves a computer that performs data-intensive tasks. So today, supercomputers are being built from heterogeneous parts, so not just conventional CPUs and memory. We're starting to see things like FPGAs and GPUs being added to these clusters to take advantage of their unique architectures to generate high-performance results. So how big is HPC? It saw about $8.6 billion in sales in 2009, with a predicted growth of about 5 to 7% for 2007. Companies who own the bulk of the market include IBM, HP, and Dell, with several others making up the rest of the market share. So what does Acceleware do, and how do we fit into the high-performance computing space? We write software that leverages the massive parallel computational capabilities of the GPU, or for that matter, any other massively multi-threaded or multi-threaded environment, such as a mini-core processing environment, or anything else that has many threads involved in its architecture. And the result is effectively a supercomputer. So how does it work? So how do we write this software to leverage this architecture? So traditionally, you would have an application, say such as Microsoft Excel. You would sum up a list of numbers. What Excel would do is it would pass that computation to the CPU. It would generate its result and return it back to the screen. That's good for cases that are somewhat restricted in scope of computation. But again, as mentioned, as simulations become more complex, you need more computations. So we take advantage of hardware such as the GPU, which has architecture designs that have many more cores than are available on a CPU. So, for example, the latest GPU has 512 cores compared to the 8 cores on a CPU. We partition the application in a way that we can submit it to a GPU. So that it's well formulated to be processed by the GPU, and that allows us to return the results significantly quicker than on the CPU alone. So the benefits to using this software is that complex calculations and simulations run up to, say, 5 to 20 times faster than a normal multi-core CPU. And this allows organizations to expand their engineering capacity by doing more prototyping and design optimization, or bringing their products to market quicker. It also allows for flexibility in supercomputing. So traditionally, there would be a centralized cluster where users would submit their jobs in a batch or in a queue, and the cluster would process it and return the results. But given that GPUs are typically a standard part of most desk-side workstations, engineers can now use our software and run the applications at their desk. Now, this isn't to say that the cluster is going away. In fact, many clusters are now adding GPU capability, so it is still a very viable and in-use type system today. But the desk side might be a little bit more practical for business units or smaller companies that don't have the capital to invest in a larger infrastructure or maintain an HPC cluster. In terms of business benefits, some of the advantages for having a GPU or massively multi-threaded software is it's a lower total cost of ownership, meaning 50% less energy for power and cooling, smaller physical footprint, so it occupies less rack space. If one GPU is equivalent to 4 nodes on the CPU, that can reduce your footprint significantly in your cluster rack. It also uses commercial GPU hardware from NVIDIA or AMD. And they have an aggressive roadmap because they make commercial products that are really targeted towards consumer graphics, things like video games and rendering. We really benefit from an aggressive roadmap of doubling of number of cores and memory on the hardware. And from the customer side, Acceleware future-proofs the applications, meaning we're somewhat hardware agnostic. From the integrator's perspective, it doesn't matter what hardware they're running on. Acceleware manages all the details of the platform, whether it's multi-core CPU or GPU architecture, or even changes or evolution within the GPU architecture. We manage and optimize for it. In terms of the solutions that we provide, we work in the oil and gas space, electromagnetics and image reconstruction. Oil and gas focusing on seismic and reservoir modeling, electromagnetic dealing with microwave, RF communications, photonics, biomedical, and image reconstruction, working to do 3D reconstructions from X-rays. This is an electromagnetic slide. It shows some of the customers that we work with. more or less 9 out of 10 of the top cell phone manufacturers in the world use Acceleware software. What they do with their software is they model they model their antennas specifically for a couple of things. The first being the signal that's received from the base station. So how much power is being received and signal strength are you getting from the base station? Are there ways to improve that or optimize it? And the other thing they look at is how much power is the phone itself radiating and how much is the human body absorbing. So they use their software to speed up that computation, which, as you can imagine, might take a long time on a normal CPU. The next slide shows some different applications of the electromagnetics. The first upper left and upper middle panels, that's really antenna design. The upper right-hand panel shows a digital camera. So what we do there is we work to improve how CMOS image sensors, which compose the pixels of the image, absorb light and actually make an image. And adjacent pixels can exhibit what's called crosstalk, meaning the light bleeds from one pixel to another. And our software actually models that and helps reduce that crosstalk so that your image is nice and sharp. Microwave ovens in the lower right-hand corner, so modeling frozen food and how it cooks in the microwave oven. And in the lower middle panel and lower right-hand panel, MRI coil design, so making sure that it's safe for people with pacemakers, for example. From the oil and gas side, again, it's a different world there. The data is massive. It takes weeks or months to process this seismic data. And oftentimes the geophysicists are just simply forced to halt the simulation so they can, at some point, just make a call as to where to go. So there's a real trade-off between quality of results. The software we work with is really focused on reverse time migration, which is considered the Cadillac of oil and gas modeling algorithms. This really lets geologists and geophysicists to get a really good idea of where the oil is located under very complex geologies. Features we support include VTI, and we're in the process of implementing TTI, which are advanced features for that product. In the image reconstruction space, we're working to speed up reconstruction times for different types of imaging. We work with micro CT scanners from GE and Scanco, which are used in preclinical trials on mice and rats to model them, or to study them. But other customer vertical markets in the imaging space include things like non-destructive testing and security as well. So as a customer example to conclude the presentation, Mike Gilbert, he's an antenna engineer at Toyon, used our product to improve his antenna design for some commercial technology and defense systems. So he was able to reduce his simulation times by a factor of 5, which significantly reduced his overall product design cycle. And that made a significant material impact to his organization. So thank you for your attendance. If you have any additional questions, feel free to contact us at events@acceleware.com, or feel free to visit our website at www.acceleware.com. Thank you.